Hi, I'm Peter Haddock and I'm in control of this video, folks, because I'm talking today from DSE, who are specialists in control systems. Why is that important, folks? Well, I talk about power generation, I talk about all these different things that we need to do to be better in the industry. But if you're in a hospital situation and the power goes out, if you're watching a Premier League game and the power goes out, if you're in Formula One and the power goes out, we've all got a big problem. So fundamentally, control systems are the things that we need to keep the power on, particularly for generators that are needed for uninterrupted power supplies. And this one, folks, the DSE 7320, is one of those units I'm going to see all the way down the factory line here being made. But first, let's see more controls here, more controls here, more controls here. But we need a few engineers to make them. Adam, you are one of those engineers. Tell us a little bit about this component here that you've got as well that we're going to be talking about.
So this is our new G8600 parallel genset controller. This is used to link multiple generators into sync at the same time.
So that's really important, folks, because if you need a lot of power, you need a lot of generators. And we're talking about things in a series there. And we're talking about how we monitor them, but also how we control them. So one's not running at full pelt when the other one is running idle. So we need these control systems to make sure that we're getting everything even and we're delivering the power that's needed right there and then, don't we?
Correct. Yep.
So folks, in order for this unit to work well, it actually needs to be put together well. And so the iPhone that I'm filming on at the moment uses the same machines we're going to see down the line as I go and discover what's all about the control systems that are made here at DSE. So let's go and see the factory floor. Cheers. So here we are at the start of the journey that's going to make one of these control units. Remember, folks, the DSE 7320, Adam, it all starts with this board.
It does.
But Adam, it looks a bit too big to fit inside this one. What's happening here?
Exactly. So to increase the production capabilities, we build these in panels of 2 units.
Right.
So each one of these patterns is identical.
Yep.
So and later on in the process, we split the panel and put them into the single units.
Fantastic, folks. And here we are in the factory conditions. Remember, some of this equipment is used to make the iPhone that I'm recording on here, because we're talking about absolute accuracy and we're talking about absolute reliability that is required for this unit. So you can't just make one, though, can you? You've got to go and get some of these things so we can stack them in the machine. So this machine, where we start here, folks, requires these components to be stacked in. So here we go. It's literally a drop-in situation. So now we've got the boards in the actual system. We're going to follow the whole line that you see here, but it's not just one line, folks. It's 2 lines that we're going to follow, because we're going to have a flip moment as we get to the second line. So Adam, it's time for us to go and see what happens next. Come on. So folks, we've now got this board, which is absolutely ready for lots and lots of components. Start with the first machine here. Let's lift the lid and have a look inside first. So folks, inside here, you'll see that that's where the components go. And this is the first part, isn't it, Adam, of where we start the whole process. Close the door so we can kick off, because basically, folks, what we've got here is where all the solder starts coming in, haven't we, Adam?
Correct. Yeah. At this stage, we have a solder stencil, which has apertures cut out for all the gold pads on the board.
Yep.
We have a squeegee that applies a solder paste along the board and covers all the spaces ready for the components to be mounted onto.
What's the type of solder that you put in here, and why is that important?
So we have an indium 4.5 halogen-free solder, which is which is made up of a number of different elements and fluxes. So it's lots and lots of tiny little balls of different alloys and flux. So later on in the process, when we heat it, all those chemically bond together to create a full solder joint.
So back with Adam here under the microscope this time, folks, because I wanted to find out a little bit more about the solder, the flux, the balls, the things that make everything on this board stick there. And so what have we got here, and what can we see behind?
So this microscope is zooming in on one single component pad.
Yep.
Here. What we can see on the large screen is the solder balls, all the different types of metal, and the liquid that they're in is the flux.
Right.
When we put them through the heat cycle at the end, they'll all combine together to create that solid solder that we're looking for.
Right, so now it's time to move on to that heat section with a new piece of equipment you just invested in. Come on, folks, let's go. So now, folks, the soldering's been done, and it's so intricate, you wouldn't believe the amount of stuff that's going there. I can now see how many components are going to go into each of these boards. And, you know, that is such a complex thing to put into a tight space. So, now, what's next?
Once this has been completed and we've done a full inspection of the solder, we then pass it into the pick and place machine to mount the chips.
And this is the process for the first check, folks. It's all about checking that everything's right at every stage. By the time you put it in, we've got to keep the line going. Come on. So, Adam, we've come down here into the clever bit where we've got all the components on reels here, and now the machine is actually placing those components right behind us here. Wow, it's crazy. There's how many components are fitted at each time?
So every pass is 16 components on this.
Right. So that is going super fast, 16 components, every single pickup. It makes me feel nervous, Adam, because it's just so quick. But we've got camera systems in here as well, haven't we? Making sure everything's placed in the right spot.
Yeah, exactly, yeah. So every time the head passes over, there's a red flash. That red flash inspects all 16 components on there to make sure that they're in the right orientation, and it corrects any twist that's maybe on those parts before it places it down onto the PCB.
But what happens if we run out the reels though, Adam?
Well, the reels won't actually run out, so we've got a system telling us how many components are left on each of the reels.
Ah, right.
So the machine will notify the operative. The operative will then splice a reel on.
Right.
Okay, and the machine will continue to place.
We're going to get that splicing moment because that's something I think I could do and help out with, Adam. Okay?
Absolutely.
We'll capture that in a moment, folks.
The machine will indicate when we need a splice, or when the machine is starting to run low of a component.
Yep.
The operative can then collect that component and then begin the splice operation. That means that the machine will never run out of parts. We've always got a constant supply going into the line.
I'm pushing down until it clicks, and then I come up, and voila, we have the spliced connection here. But then the next phase for this, folks, is to identify this with the machine. So Mark's going to come over and help me do that process. The delicate hands of Mark, folks. So this is now identifying in the machine that we have got a component changeover here. First thing he's going to do is identify himself. That is his unique code. Then he's going to actually go into the system, identify the reel. That's again a unique code. And then as we come back, folks, he'll put the amount of components that were due into that reel, so the machine knows what's coming in to the reel, and therefore, you know, how it can display that information as it moves forward, and then tell us when it's coming up for a little change required as we move on. So thanks very much, Mark. It's been great to see you working there. And just got to slide it in, folks. And we are now absolutely ready to go to the next phase. So now, folks, I've got some tweezers because, I'm sorry, Adam, I'm going to be a bit cheeky here, because all of these things, and we're talking about productivity and efficiency with all these machines, we're talking about testing and things like that. But testing's there for a reason. Sometimes things do go wrong, especially if you've invited me here with a pair of tweezers to dislodge one of your components, Adam. So I'm going to do that right now. So follow the tweezers in, folks, as I make the really, really bad decision by changing the component off here and putting it at about a 45-degree angle. You can see there that there's solder patch underneath there. So it's all been changed, folks. That is not a nice thing to do to you and the team, Adam, but I'm doing it for a reason, because we're now going through another machine. Tell us about the machine you see behind us and what stage are we at now?
So we've got to reflow now. So this is our reflow oven, which heats all the components and the solder paste up to 260 degrees.
Right.
Creates that chemical reaction that we spoke about earlier, which forms a solid solder joint.
Right, and this is what it's all about, folks. And you used to have a unit that was slightly smaller than this, but actually you've recently put this unit in because, again, like anything that you heat up, you want it to heat it up gradually, folks, so that therefore everything heats up to the same temperature, and that adds in that quality and efficiency. Even if it's 0.5% of an improvement or even fractions of that, All of this makes a difference when you're talking about the uptime of your control unit to help the uptime of all of the critical things in there, isn't it?
Correct, yeah. So by extending the profile, so a slow ramp is what we call it, that will then increase the longevity of the components. You're preventing a thermal shock happening by just heating straight up to that 260 degrees.
And nobody wants a thermal shock, folks, because I'm hot enough as it is in here. So now time to see really whether my intervention actually can be picked up, folks. So we're off to see the bad man's board get picked up. See you later. So we've just had a good board go through, folks. I'm next. Let's see if I've messed it up enough for the machine to detect it, and let's see how it looks, because Adam, there's a system here that's going to detect all that through cameras, and it should show us on the screen as well, shouldn't it?
Correct, yeah. So
this is an exciting moment.
So this system here has 15 cameras inside it. Here it is. Has 15 cameras inside it, which create a full 3D image of every single component that we've just placed onto that board.
Right.
So we can see here, your component has been flagged because it's not in position.
That's it, because I twisted it to that extent as well, didn't I?
Correct. We can also see down here, we've got the full 3D image built of that component that we can turn around and look at the full sections of it.
And we can see here, folks, that that whole piece there is where it should be sat on. So that is absolutely brilliant. So, Adam, I tried to mess it up, and I failed, folks. But that's what it's all about, isn't it? Checking,
Correct.
double checking, having these systems, having the camera technologies, having the components all lined up, all put into the right flux, the right solder flux system. And then we've got to now go to the next bit where we're going 180.
Correct.
We're literally going to flip this board, folks. And I'm like, why are we going to do that? We're going to find out in a moment. Come on, Adam, go that way. So now, folks, we're going to take the stack from the previous line and put it into this line. So I've got a stack here full of the components ready to go. So we'll pop it in here nice and carefully. Adam, would you do the honors and press the button, and there, off we go. It goes, come on here, folks. We see it going right down now into the system, which is fantastic. So we're now on the second line, folks, and this is where the board's been inverted with Adam. But we see here the reason why this is a second line, bigger components spliced together again as we're going to start the run now to make sure we've got all the components ready. But specialist casings as well for these products. Why is that the case?
Absolutely. So these cases protect the products from ESD, which is electrostatic discharge.
Right.
So where you get your shock when you touch a metal door handle or something like that. So these components are very, very sensitive to that.
Yep.
So they need to all come in the specialist casings to protect them.
So what's really fun, folks, is now we've got the flipped board with all the components on it. This one's been tested by the same system that we had previously, but all of those components are now on this board and ready to go to the next phase. Super cool. So I'm back here with a coin cell battery that keeps the real-time clock going on the PCB. But, folks, they've let me at it again. So I'm going to do something pretty sneaky. I'm going to put in this one the right way round and the other one in the other way round and see if the system here, which is a brand new system, fails me and fails this board. Okay, let's go for the first one. Right, so we've put that the right way round. Notice coming into that, whoops, that shouldn't be there. It should be the other way round. Now we're going to send it so that we can see, folks, whether the machine will spot that I've been a naughty operator and put this the wrong way round. Right, Adam, I've done something naughty again, putting the coin batteries in. You weren't there at that time, but I've proved the system works at the last time. Let's see if this brand new fault is coming in and this brand new system. This is quite interesting because it's from Falcon, who's literally up the road. Again, this is you as a business supporting local other businesses in your sector, isn't it?
Yeah, absolutely. This is a 2D camera which inspects all the components on this board that we've just placed at the last operation and checks for the orientation to make sure that's correct.
Send it, Adam, send it, go. So as it races forward, folks, you know, for me, this is yet another point in the process of quality and inspection. Let's see how it goes. The moment of truth. Have I put them in the right way round or the wrong way round? Has it picked it up, folks? Little bit of red there. Something has failed. I failed yet again to break the system here at DSE. Time to go and see some more. Right, so this is really exciting now, folks. Live here, we've got a solder fountain actually then coming into the board from underneath where we've seen earlier. This is another clever little thing that we've got here that makes sure that the soldering process works, isn't it?
So we apply a flux, we preheat the board to a temperature, then we place it above 4 solder baths, independent solder baths. They'll track the safest route and the quickest route and optimize the process of soldering the components that we've just placed in.
Fantastic. So who'd have thought I'd have seen a solar fountain today, folks, doing the job. Cheers. So here it is, folks, the board, and remember, the ones that I tried to failed. So this is a board that's passed all the tests front and back, and now it's time to do the really clever stuff, and that is to put in all the firmware and software to this board that goes then into the control system. And that's where the clever engineers here have designed all of that software, firmware, and they've even designed their own bespoke system here to actually load it all up. Now, I've got to just pop the board in here, wiggle it around a bit to make sure I've got it in properly. And now, the moment of truth, we're going full digital, full controls right now, folks, as we're loading it all in. Adam, time to bring you back in and remind people what is the product that we're just creating the final clever bits for.
So this product allows you to control your generators essentially.
Yep.
So it keeps the generators running when you have a blackout or a brownout in different environments.
Yep.
So this, what we're doing here, this is putting all the tests into the units, all the real-time clock, so all the functionalities that the unit has. It also tests each button that we've placed on the unit, and also checks all of the LEDs that we've placed to make sure that the correct brightness, the correct colour.
Right. So we can actually see then everything on the screens when we need to control it, start it, stop it, do whatever we do. And the thing about all of this is this machine, I've had to wait a little bit before this machine's come on, because this is the first of the batch that we're putting in, because that's gone straight to the server here, got the latest version of everything, double checked that, and that's coming through here. That's again another test, isn't it, to make sure that each time we go and test everything and we make sure we've got the right stuff going in the right place every time.
Correct, yeah.
So it's time to go and take this to the next section. So now we've got the unit fully put all together. So now we're going to test the screen and the clock that we put in earlier, the battery for. So pop it straight through here, push that down, plop that in, and now we start lighting the console up here. It's then booting up, then it's going through the system here. Status, we've got all of this, ticking everything off. We're now testing the screen. It's flashing. Yes, I can see it's flashing, so that's a good thing. So therefore, all of the display elements are working for this particular unit. That's now ready to go to the next and final phase. But what they forgot to tell me is I need to press the green button twice because it's a sounder on it as well. So here we go. Now's the time we get the sticker. So here it is, folks, the little sticker. I can take this out now, and then we just pop that here, folks, to show that it has all been tested and ready to go to the final part of the process. So here we are, the final inspection, ready to go outside. We've got all the labels in here and everything like that. This machine's testing absolutely everything. But of course, I've been a bit cheeky. I've pulled the label out, and we're going to see at this final moment whether this passes the ultimate test. This is a machine, again, manufactured by your supplier up the road. And again, you're working with a local supply chain here. Only 2 of these are in existence. One is here, and the other one is coming here, folks. This is a bespoke system, isn't it, for you?
Yeah. So this was created for us again by D-Tech. So after a number of conversations and really nothing being on the market there at this level to cover what we wanted, we came up with this design with the guys. 2 cameras, one facing up, one facing down.
Yep.
What we do is we put the unit in, the camera's take an image, check against the reference image, again, looking for connector orientations, correct labels, correct rear cases, and labels being put in the correct place.
Not quite in this case, folks. So let's have a go. It's another moment of truth. Will it detect the fact that I've been naughty again? So we're starting the process now, bringing up all the different things. Look, we can see on the screen here, oh, inspection failed. because again, zoom straight into the area there. So just a proving point that test, 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 and test again, and therefore you'll pick up everything, including the label that tells you what the component is. Great to meet you. Thanks very much for taking me a journey around this establishment. But I want to do one final thing, Adam, and that is to go in and make sure these are delivered to the customers effectively. So folks, time to go into the warehouse. So the final thing for us to do is go and pick the stock off the shelf, Adam, so that we can get control systems all around the world, so the people that matter, so that you can be in a hospital with a critical power working, so that you can make sure that you have that Premier League experience at the weekend. All of these different places use all of these different control systems and backup generation. So it's critical we get everything right and we get this stock out. So let's get up there and pick our stock ready for delivery. Off we go, folks. So Adam, we're ready here now to pick off the stock. Let's get a pallet off and then we can get it delivered to everybody. So it's been fantastic to take this journey around the DSE team, around their facility. Adam, it's a pleasure to meet you and the team. Keep on getting those control solutions so that we can all have our emergency power and that critical power when it's needed. Ta-ra, folks.